get started. Performance of web applications. Now, what does come to your mind when you think of this term? The term which is performance of web application. Most of us use technology in a day-to-day life, and this has become part and parcel of it, right? For example, whether to go book a train ticket, whether to pay bill, whether to even download a form for your kids' admission, or whether to go and record your work hours, or even, for example, tracking your expenses, etc. We do internet, we do use internet, we do use web-based applications. Now, again, when we visualize, what does performance of these applications mean to us? Now, most of us would have had experience. It could be good or bad. Good means you go to a web application, you click on a button, it responds as if you're talking to a friend. You complete your job, happy, you come back. That's a very good experience. You're going to go and use that application once more and many more. You're an happy customer. So let's visualize a scenario where you entered all your information into a form. You're clicking on a button. It either shows the progress bar for a long time, or at times you just get page not found exception. Initial reaction itself is not good, right? You feel, oh my God, I have to enter all those details again. So it leads, so you probably will do it again depending on the type of operation that you're doing. And then twice or thrice you get frustrated. You probably will think twice before going and using that application again. What is all leading to? It is all leading to unhappy customers. It is all leading to loss of revenue for an organization. And it's very difficult to attract this customer to your web application again compared to someone coming newly. But even if more new user comes in, they're going to have the similar experience and they're going to leave. Now, why does it take longer? Why does when you click a button, why you don't get the response? When do you need to care about it? When do you need to think about it? Many times it happens that the solution is built, it's deployed, users are using, they are complaining, and then organization gets into doing what is called as postmortems. These postmortems are expensive, and this needs to be done in a very stressful manner because it's a problem to solve. It's not in a solution to be built in future. You have a problem, it needs to be solved. Also, it's not surprising, depending on the criticality of the application, a war room can be opened. It may work 24/7 until the solution is found and the problem is fixed. Now, why is that we are caring about performance now? Why is it more relevant now? Let's look at some of these statistics. It took 30 years for radio to penetrate up to 50 million customers. It took only 15 years for TV to do the same. And let's look at Facebook. It only took 2 years. What is all this data telling to us? All these are saying that gone are the days when the development team could say, let's first get the functionality out. Let it work first. Depending on the number of people, we will see whether we need to improve anything with respect to performance. Gone are those days. We are in the era where if we are developing the solution, we need to care for both functionality and also performance, because if either one of them fail, it's a failure for the solution. It's a failure, it's an impact on brand image, it's a loss to revenue. More importantly, it leads to unhappy customers. So all of these are coming to a point where performance of the web applications are critical. So what, right? So what do we do about it? And what is that we need to keep in mind when it comes to performance of these applications? What are 3 major things that we need to keep in mind that we call as performance targets? The first one is end user response time. That is, when somebody clicks on a button or when somebody enters a URL, how long does it take to get the response? Visualize this. Let's say you're talking to a friend, you're talking to a new person. You asked a question, how long does it take for a person to respond? At times you get it quickly, at times the person thinks and responds, at times you may not get the response at all. So the time taken is the critical one. The second one is throughput. How much can you get done within a specified time period? For example, how many bills can be generated in an hour? How many reports can be generated in an hour? How many cookies a cookie cutter can cut in an hour? How many pizzas can be made in an hour? Right? So amount of work done within a time period is what is called as throughput. Now what is the third major one? The third major one is volumetric. The volumetric is the one which provides context to the two parameters or the targets that we talked about, which is response time and throughput. So when we say a response time of 3 seconds, this we click a button, it should take only 3 seconds for it to come back with the response. What is the context at which this is relevant? Is only one person using the system, or is hundreds of people using the system, or millions of people using the system? Right? How many simultaneous users are using the system at the same time? Now one could be logged in, right? Many people go log into their online banking system. Now that does not mean that all of these users are clicking the button at the same time. So another important aspect that we need to care about is simultaneous request. That is, given that the users have logged in, how many requests come at the same time? Another very important question. Are these numbers same? Are these numbers same throughout the day, throughout the month, throughout the year? Most probably no. It does vary. It does vary by seasons. It does vary by day of the month, day of the week, hour of the day, etc. For example, if it's a shopping website, it will probably see more load during Diwali time frame. If it's a website by selling gold coins, it will see more traffic during Akshaya Tritiya. So there are going to be peaks. There are going to be peaks when this application will see more traffic. And also in terms of growth, will the number of users remain constant? No. More and more users are going to come in and use the system. And what is the expected growth in next couple of years? It could be 3 years, 1 year, whatever is relevant to business. To summarize, when we talk about performance targets or performance of web applications, we need to remember three key things. One is, what is the expected response time to keep the end users happy? What is the throughput requirement for this application? And under what context, under what volumetric this is relevant? Now let's say, yes, we started a project, we got to know the use cases, we said this is the response time, this is the volumetric, these are the number of users who are going to use the system. And the project started. And as we can visualize, a project is not going to be delivered by just one person, one team. It's going to be a set of people working together to deliver this. It could be a business analyst, it could be an IT architect, it could be a set of specialists working towards and making this happen. Now, does this performance target mean the same to everybody? At a larger umbrella, yes. Response time remains response time, throughput and volumetrics remains same. But the context or the granularity at which they look at it will keep changing. For example, if an end user is looking at the response time, as I was mentioning, what it means is I click on a button and how long it takes to get the response. But what does same response time mean to a person who is developing a piece of code? For them, the response time is how much does this particular method take, or how much does this particular module take. Now, how do we bridge, or how do we create a bridge between the end user response time and the time that the developer should care for? And how to do it? Most often we see developers saying, my code will just take 1 second or 2 seconds. But it is not uncommon to see 10 components stitched together to provide a use case to end user. So that one 3 seconds. So all these are again boiling down to a point. It's important to define targets. It's important to know what it means to people working in different phases of life cycle. Now let's look at how to achieve it. Understanding that it is important. More often, only way to do this is to have the discipline of having performance engineering incorporated and adopted into the life cycle throughout. Now, it's not surprising to see when we go and ask, what are you doing with respect to performance engineering? Most often, we will be shown performance test plan. And most often, being introduced at the end of the life cycle, just before it goes live. It's almost like going into post-mortem state. Only difference is that you are probably doing the post-mortem before deploying it or making it available to end user. Now, so what is the key? End-to-end performance engineering is the key to meet performance targets. That does not mean we choose 100% of the use cases and do this rigorous exercise of performance engineering for all. Usually we use 80-20 rule or 30-70 rule. Choose the ones that are business critical, choose the ones that are voluminous, and spend energy on them. Usually performance engineering activity is a trade-off between how much cost we need to spend versus the risk of that particular use case not meeting performance target. So let's take a look at how does this end-to-end performance engineering lifecycle look like, starting from proposing the solution till the time we deploy. You would see a number of boxes which talks about what all needs to be done. Again, as I was mentioning, the key is when we do it, what we do it, to what extent we do it. Right time, right task, and right depth are the key. And choosing the right use cases are also key. So when we talk about these 5 tips, we will touch more into the 3 phases of the life cycle, which is detailed requirement analysis, high-level design, and low-level design. The benefit of looking at these 3 life cycle phases are that you can catch problems early. You can avoid the post-mortem stage. So far we have seen